Hello students, how are you all? I hope you all are doing good. So we will proceed to a further part. So we had ended up till here, I had given you points. Next we have the properties. Before that, one more I can tell you that our log and our exponential function both are mirror image of each other. Now suppose this is your graph. Yes, your e to the power x graph is probably in such a way, right? And your logs, it will be in such a way. It comes here. This is your y is equal to x. Y is equal to x line, and this is y is equal to log x to the base e. Here our point, so in your e to the power x part, it lies on which 0 comma 1, and your log x, it will be 1 comma 0. So as you can see, this will be going on increasing and this will be like this, it will be going on increasing. So they both are mirror image, you can tell, right? This is upward and this is downward. So this both are mirror image of each other. Now we'll see to the properties. We'll go for the properties. We have some properties which will be useful for you to do your differentiation. So your first property is change of base property. Change of base property. Now see, if you have like log b to a, log b to the base a. What I've said you, whenever we take for a natural logarithm, our natural logarithm which is e, whenever you do log, so directly you can take as a log x. Yes, you can directly take as log x in your calci. So to make that, our basic property, first base, when you have different, you have your number b and the base is a. So how you will do? We have to change it to log b divided by log a to the base e. Both will be changing to the base e. Like for suppose you have log 7 and base 10. Now if you have such thing, how you will find out the value? So for that you have to use this property. It will be what? Log 7 to the base e whole divided by log 10 to the base e. Because this is our natural logarithm, so directly you can do log 7 value, then log 10 value. Understood? So this is change of base property. When you have base different and the number is other than natural logarithm, you have base different, then you have to use change of base property. Second, you have log of products function. Now suppose you have log mn to the base e. So how we have to do? Log m to the base e plus log n to the base e. If most of them may get wrong also. See, for suppose if you have log 7x plus 5y, okay, if you have like this, you can't do this. 7 5s are like 35xy. This is totally wrong. Log mn is log m plus log n, but log of m plus n equal to this is not equal to this, okay. In such a way you shouldn't do, that is wrong. This is correct, but this is wrong. Don't go to, if you get like this any answer log of 7x plus 5, just leave it off. You no need to do anything. That will be like your final answer, okay. Please make sure of that. Third property you have in quotient, that this was your product. Now quotient also log m by n to the base e. So this will be log m to the base e minus log n to the base e. As you have your identity properties, yes, m into n means how you do m plus n. M by n is m minus 1. In the same way for log 2. Even in your m by n also, here also if you have m minus n, log m by n you can't do. This is also total wrong. This is not proper formula. This is wrong and this is wrong. Your proper property is this. If you get log of m minus 1, just leave it off. Don't do anything. If you get late, just leave it off. That will be your answer. Now the fourth property you have log m raised to n to the base e. If you have anything with raising power, so that power comes here. See, this will go here. This power comes to the starting point of your log m. It will be n log m to the base e. For example, you have log 4 to the base e. So this I can write as log 2 log 2 to the base e. I can write it like this, right? 2 log 2 to the base e. Why come 4? How I can write? Log 2 square. I can write 4 as log 2 square to the base e, means it becomes the same. 2 log 2 to the base e. One more property, this you see, when you have log e to the base e itself, it is equal to 1. Yes, we have done this. Log e to the base e is equal to 1. Same for log 10 to the base 10. If they are same, the number and the base are same, it will be always equal to 1. If you have log a to the base a also means it will be 1 itself. Provided your base value, whatever it is, it should be greater than 1 and the number, whatever you get here, should be positive. Base should be greater than 1 and number should be positive. I have written here. One more property. This is like, kind of multiple question, a very important question it is. E log phi to the base e. If you have like this, e raised to log phi to the base e, then your answer will be phi. Whenever you have e and raising log to the base e with the number itself will be your answer. Now for example, if I have e log 2 to the base e, e raised to, see it is e raised to log 2 to the base e, the answer will be what? 2. The answer will be 2 itself. One more I will take. If I take e log x square to the base e, e raised to log x square to the base e, the answer will be what? X square. Yes, the answer is x square. Suppose if you have e 2 log x to the base e, the answer will be what? X square only, na? Yes, because your 2 goes here. This property changes to e log x square to the base e only, right? This is the same property of log mn. It will be what? N log m to the base e. If you have such, you should get it in such a way. So it is the same. 2 log x to the base e means it will be x square. X square means how? Log e x square it is. It changes to this property. When you have like this open, you should make it in such a way. If you have in such a way, make it to this. Okay? We'll proceed to our exercise part. Differentiating with respect to x. Our first question is e to the power x divided by sin x. So we will denote it first. We'll take let y is equal to e to the power x by sin x. So for differentiating this, you can see it is in a quotient rule, right? What our quotient rule tells. So this you can see in our quotient rule, and what our quotient rule tells, u by v. If it is, how it will be first? V, then du by dx minus u dv by dx whole divided by v square. In the same way, we're gonna do. So these problems are simple, easy, very easy. Here you have to go for quotient and product rule itself along with our chain rule. So we're gonna apply the same differentiating with respect to dy by dx. First, I'm taking this u, I'm taking this v. First, keeping v as it is and differentiating u minus keeping your u as it is, differentiating your v whole divided by v square. So let us differentiate sin x. This remains as it is. So this will be sin x. Differentiation of e to the power x is what? It is e to the power x minus keeping e to the power x as it is. Differentiation of sin x is what? It is cos x. Yes. Again whole divided by sin x, the whole square remains as it is. So this will be sin x the whole square. Here either you can do separately this your simplification, or from numerator you can see e to the power x is common. So I will take e to the power x common, and left is what? Sin x minus cos x whole divided by sin x the whole square. So this will be your final answer. Again, if you want to simplify means this separately you have to do. Next problem, e to the power sin inverse x. So here also see, take first let y is equal to e to the power sin inverse. To differentiating with respect to x, dy by dx. So first what we have to do, see here you have two terms. First e to the power x, and then again you have sin inverse x. So means here again we have to apply our chain rule. So differentiating first e to the power sin x. So d by dx e to the power sin x. Again d by dx of our sin inverse x. Okay. So differentiation of e to the power sin inverse means how it is e to the power x, right? E to the power x only it is. And differentiation of e to the power x is what? E to the power x. Differentiation of sin inverse x is what? 1 by root of 1 minus x square. So finally how you can write? E to the power sin inverse x whole divided by root of 1 minus x square. So this is your final answer. I hope you are getting it. Our next question, sine of tan inverse of e to the power minus x. So here you see, you have sin x you have tan inverse x and you have e to the power minus x, means e to the power x, and plus again you have here minus sign. So how many times you have to differentiate? It is again chain rule 1, 2, 3 and again here 4. So write let y differentiating with respect to x. So it will be dy by dx. I am writing this for everything. It is for you right now, you have started. So be writing it or try to directly differentiate if you have understood. No need of writing every time this step. Okay. So first differentiating our whole term, sin x. This will be whole x for sin, right? So sin x. Again differentiation of tan inverse. Okay, tan, and for this x will be this. This part is your x. This has replaced x part. Again differentiation of our e to the power minus x. E to the power minus x, and again here minus x is there. So even for this also you have to interior differentiation. So d by dx of e to the power minus x. Okay. So what is your differentiation of sine? Differentiation of sine is what? Cos. So this becomes cos, and our x part is this. This differentiation of tan inverse x is 1 by 1 plus x square. X is what here? E to the power minus x. Differentiation of e to the power minus x is what? E to the power minus x. Again minus x differentiation is minus 1. Okay. So we will say it. So differentiation of this will be what? Sine is our cos. Yes. And our x is what here? Tan inverse e to the power minus x. So differentiation of sine is cos of tan inverse e to the power minus x. Differentiation of tan inverse x is 1 by 1 plus x square. Differentiation of e to the power minus x, e to the power minus x into minus 1. Differentiation of minus x is minus 1. So this in total how I can write? So simplifying this, minus e to the power minus x cos of tan inverse of x whole divided by 1 plus e to the power minus 2x. This e to the power minus x square it will be now, this 2x you can multiply only. So this you can write as simplify finally. Okay. Our next question, 7th one, root e to the power root x where x is positive. X is positive they are telling. So solution, let y is equal to root e to the power root x. See here how many times you have to differentiate chain rules. How many you have? Root e to the power root x and again here root x. So this is 1, this is 2 and again inside this is 3. So there are 3 part. So there are 3 part, right? So I have written here differentiating with respect to x, d by dx, differentiation of first with the root x, again differentiation of interior e to the power root x, again differentiation of root x. So 3 parts. So we will do our root x differentiation directly. I have already said you root x differentiation I have said you it is 1 by 2 root x. So this also comes in the same way. So as you can see, differentiation of root e to the power root x is 1 by 2 root x. Here root x is what whole? This. Yes, here root x differentiation is 1 by 2 root x. So it will be 1 by 2 and this again whole root x into differentiation of e to the power x. E to the power x is what? E to the power x itself, but here x is what? Root x. So it will be e root x. Again root x differentiation is 1 by 2 root x. It is 1 by 2 root x. So this how I can write? Simplifying here only I will write. Can write e to the power root x whole divided by, see, 2 into 2 is 4. Here you see this is also root x, this is also root of e to the power root x. So I can take in one root only, root x e to the power root x. So this becomes your final answer. Okay. Your next problem, cos of log x plus e to the power x. So here also you can see it is first cos, then log x ex. See here it is plus, means this can be separate differentiation. First will be a whole cos, then will be a log x plus e to the power x. This separate you can do. Let y write it differentiating. So I have written is dy by dx plus differentiating your cos x, then differentiating your interior log x plus e to the power x. Okay. So differentiation of cos is what? Minus sign, right? So minus sin x. X part is taken by what? Log x plus e to the power x. Differentiation of log x plus e to the power x. This you should do separate. Differentiation of log x plus differentiation of e to the power x. If you want, you can write that step, or if you understand this when it is in addition and subtraction, it will be for separate. So differentiation of log x is what? 1 by x, and differentiation of e to the power x is, here plus is there, take the bracket, plus e to the power x. So you have got the final answer. If you want, you can write this inside. So this is into, right? This is whole term into this, whole term into this. So if I want, I can write it as minus sine whole divided by x. Again for this it will be minus e to the power x sine of log x plus e to the power x. This is your final answer. If you want, you can leave it here also, no issues. If you want, you can multiply also inside. It is one and the same. I hope you have understood these problems. Please go thoroughly. It's very easy. Just be proper with the differentiating, how you are differentiating. Okay? We'll meet up our next topic in the next class. Thank you.